Hey class, 3.3a is on solving quadratic equations, specifically quadratic equations that you can solve by square root method. So ones you can solve by square root are quadratic equations that are missing that bx portion. Like this one, we have x squared and we have plus 23. We don't have any just plain x terms. So you can isolate the x squared and then solve by using the square root. So you need to get the x by itself first. So you're going to start here by subtracting 23 on both sides. You get 2x squared equals, let's see, be negative 18. Divide by 2 on both sides. Bring this over here. I'm going to run out of room. I'm going to get x squared equals negative 9. Then I can square root both sides, and I'm going to get x equals, and since the square root of 9 is 3, the square root of negative 9 is 3i, and also negative 3i, because 3 squared is 9, and negative 3 squared is also 9. So two answers. Sometimes we write it as plus or minus 3i. Remember, we get that because negative 9 is the square root of negative 1 times 9. Square root of negative 1 is I. Square root of 9 is 3. Okay, this one you can actually solve, example 2, by square roots as well, as long as you don't FOIL the parentheses. So x minus 3 is the same square, does mean x minus 3 times x minus 3. And multiplying it out, you could, but if you just leave it as it is, you can take the square root and avoid having to multiply it out. So I'll show you how that works. So you need to isolate this piece, the whole piece, because that's what includes the x. So I'm going to start by subtracting 8 since it's plus 8. And you're going to get 2 times x minus 3 squared equals negative 8. 2 times, so I'm going to divide by 2 to get the parentheses by itself. And then I'm going to get x minus 3 squared equals negative 2. Now, to get rid of the square, you can take the square root of both sides. And then the square root undoes the square. So on the left, you just get left with x minus 3. On the right, the square root of 2 is irrational, so you want to leave it as the square root of 2. But you pull out the square root of 1 as I. So it'll be I square roots of 2, and it is plus or minus I square roots of 2. Then you have one last step is to add 3 to both sides to get x by itself. And then we write this as 3 plus or minus I square roots of 2, because we cannot combine the 3 and the I square roots of 2 because they're not like terms. And when I said I had plus or minus I square roots of 2, I really had positive I square roots of 2, or negative I square roots of 2. And I added 3 to both of those. So this is another way of listing the answers. 3 plus I square roots of 2 and 3 minus I square roots of 2. Okay, we just need to isolate our variable here. I gotta turn the, which is our x squared. So we're going to want to move the 17 first. Since it's positive, you want to subtract on both sides. The negative will still come down, so it'll be negative 4x squared equals, these are both negative, so you can add them together and keep the negative. The negative 4 times x squared, so divide by negative 4 on both sides. And 36 divided by negative 4 is positive 9. Then square root, and we're going to get x equals plus and minus 3, or x equals 3 and positive 3 and negative 3. Either way you want to write it, as long as you understand that plus and minus does mean both answers. Here's another one with the parentheses. So you want to isolate just the parenthesis piece right here. So we'll start by adding 21 to both sides. Then it's 3 times x minus 2 squared equals 21. Then we want to continue isolating the x by dividing by 3. You get x minus 2 squared equals 7. Then take the square root of both sides. Since the square root of 7 is irrational, we're going to have to leave it as just the square root of 7. And over here, the square root takes out the square to be x minus 2 equals. It is positive or negative square roots of 7. We add 2 to both sides. X equals, so I have a whole number and an irrational number. So I could add those together with a calculator and get a decimal. But if I wanted to leave it as an exact answer, it's going to be 2 plus the square root of 7 or 2 minus the square root of 7. That's what x is going to equal. Commonly, it's just written as 2 plus or minus the square root of 7. Now, you could use a calculator to approximate that. Let's see, the square root of 4 is 2, and the square root of 9 is 3. So the square root of 7, 4, 5, 6, 7, 8, 9, it's probably going to be about 2.7, somewhere in there. It's really close to 3. So you could say 4.7 and negative 0.7 as approximations. I didn't use a calculator, and so I might be off by a decimal or a tenth of a decimal. But I want you to use the exact values anyway of x. All right, so when you have a fraction, you can either remember, if you have a fraction, when solving equations, you can multiply by the reciprocal. So that works, so multiply by the reciprocal. Or you can think of it as in 2 steps. So like if you have 1/2 is easy to multiply by the reciprocal, but if you have like 3/4 x equals 6, sometimes it's easier to do it in 2 steps instead of multiplying both by 4/3, to multiply by 4 first, because that will clear out the divide by 4, and then you get 3x equals 24. Then go on and divide by 3, and you get x equals 8. Which is the same thing as you would get if you started out right away by multiplying by 4/3. So either way, you can either do it in 2 steps or multiply by the reciprocal. Since the reciprocal of 1/2 is just 2, I'm going to multiply, because it's 2/1, both sides by -2. Both sides by -2. Because -2 times 1/2, that's just going to be 1, and negative times a negative is going to be 1. So this reduces to 1. I get x plus 5 squared equals 8 times -2 is -16. So remember to keep the equation balanced by doing it on both sides. Then I can take the square root of both sides, and I'm going to get x plus 5, because the square root will take out the square. And the square root of 16 is 4. And the square root of -1 is I, so this is going to be plus or minus 4i. The last thing I'll need to do is subtract 5 from both sides. I want it to be in standard form, so the real part first. So I'm either going to have -5 plus 4i or -5 minus 4i, commonly written as -5 plus or minus 4i, just all together to save some time. See, do one more, and the rest look like extra examples if we need them, but do one more for you. So here I'm going to start by subtracting the 3. I want to isolate the x squared. -1 x squared equals 28. Divide by -1. X squared equals -28. Take the square root of both sides. And I know that I'm going to have a plus and minus I square roots of 28 to take out that negative. And then I want to see if 28 can be reduced at all. So square root of 28 I could rewrite as 14 times 2, or that would really be 7 times 2 times 2. So same thing as 7 times 4. So there's a perfect square under there. The square root of 4 is 2, so the 2 can come out, and then the 7 would stay. So if you learned it with the factor tree, essentially you're taking factors 14 and 2, 2 and 7, and then these make a perfect square. So you can take the 2 out, and the 7 stays inside. Or you think about it as the square root of 7 is irrational, square root of 4 equals 2. That comes out front with the I. So, and you have two answers, positive or negative, because if you square them, they're going to equal back to our original answer. All right. Hopefully that was helpful. There's some extra examples. If you want to practice them, come in for help. Sounds good. Have a good night. Thanks.